So this week we're going to talk about forecasting the weather. Uh, we've talked a lot about a lot of different variables and how they all interplay with each other. So this whole lesson this week, after we get through the hurricane part, is going to be about forecasting. It's putting them all together. So let's just take a look at a current National Weather Service map. This is all the highlights of hazardous weather in the United States currently. If you look at this, notice all this area of heat, southern Ohio, all the way back to the Midwest, along the East Coast. And then there's this area of fog, too. And here, if you were to zoom in on Ohio, we actually have some severe thunderstorm warnings. So this is just a broad idea that, okay, currently there's a lot of hot weather across much of the United States. However, the northeastern U.S. has some fog, and there's some severe weather here. So now that we have a broad picture on what's going on, let's look at a surface weather map. So the current surface weather map, here we have a big high pressure, well, not really big, but there's a high pressure over New England. What it's doing is pulling cool ocean air inland over parts of New England. This is called a backdoor cold front. Notice it's all the way down here in the northeast North Carolina, the Outer Banks. And the winds, think about it, they're clockwise. So they're coming in off the ocean. Uh, my wind shifted today here. Where I live down here in southeast Virginia, it went from a more of a southerly or southwesterly direction. Now it's easterly. And what that is doing is pulling in some moisture. Uh, and it's actually keeping it just a few degrees cooler where we are. However, if you look up here in New England, it's 60, 64. So they are definitely under a cooler maritime polar air mass. So there are maritime air mass that's coming in from the northern Atlantic into this area. So now, right along this boundary right here, there's thunderstorms that are popping up and stuff too. Now look down to the south. We have big high pressure along the here. Planetary circulation said we should, and it actually is there this summer. Moisture coming up from the Gulf and into this central part of the U.S. and temperatures 95, 93, very hot. That jives with what we just saw on that map, talking about the heat and humidity there. If I wanted to look at how this pressure, how these things have changed, I could go back 12 hours. Notice cold front up here that's now down here, kind of dissipated in this part of the world. This cold front has started to drop into North Dakota, northern Minnesota. So we've had a pretty hot week here, especially across much of the Midwest and all. So let's take a look a little bit upstairs on what's going on. Upstairs, big high pressure at 300 millibars. Matter of fact, you can see the clockwise circulation around it here, and there's a jet stream where it's at way up in Canada. So the jet is way up across the northern United States here, well even north of most of the United States. And here in New England, pretty strong jet streak right there. And there's pretty strong convergence aloft in some of this area here. That's why that high pressure built. And that high, literally, there's a little bit of a ripple to the southeast that helped it to push south right here along the East Coast. Didn't move inland much, but it's right along the eastern United States. Now here, we find lots of potential moisture coming up, heat coming up. And remember, if you're looking at high pressure aloft, you've got a lot of warm air underneath it because the pressure is not falling as fast. So let's take a look now a little bit lower down in the atmosphere. All right, I'm looking at 850 millibars. Notice all the southerly winds coming out of the Gulf of Mexico pulling moisture north. Notice here on the East Coast, all the northern winds coming down, bringing drier and cooler air, much cooler air. Here's 6 degrees Celsius air. That's significant compared to down over us. I have 20 degrees here, 20 here, 23 out in this area. So very warm air out of this part. Also, moisture up along this boundary, where it used to be a boundary up in here. So we now put together a picture of what's happening currently. If I were to look at this on satellite as well, this is the current satellite image, and we'll just take it as lightning flashes and visible. There's a lot of thunderstorm activity here across central Ohio. Really some very impressive lightning here around the Columbus area right now and across the eastern parts of Ohio, along the old boundary that literally has dissipated, but you could see that area of moisture that pooled up in here. Well, that area of moisture allowed these thunderstorms to begin because moist air is unstable. And we can see over here in the eastern part, we're getting some thunderstorms right along the old boundary there. Remember that boundary went inland? Well, here's the thunderstorms allowed to develop there. So we're actually seeing what we think we should see in this system. Let's go back on this one. I want to go back a little bit here, and we're going to change the sector. So in order to do that, I'm going to go to a CONUS, East CONUS, and we want to look, let's just bring it down here, and we'll look at a water vapor, mid-level. Why am I picking that? Water vapor really shows the jet stream many times and troughs pretty small scale. Notice big high pressure. Here's Florida. It states all of that pushing the moisture around it up. Dry right in the middle of this high. Here's a quick jet up here and another one over here. So what you're seeing is what we looked at on the maps. Actually, they're verifying pretty well. There's a little bit, I would argue, there's a little bit of a curvature here. Might be causing these thunderstorms along. They're all on the southern periphery of the jet stream here, where the moisture is coming up. All right, so we want to project this. There's a couple ways we can do this, and I want to just take one computer model. I want to know if this big high pressure is going to stay there. That's the first question. If it's going to stay there, then I'm looking at very much no change in these conditions. So let's go look at, this is the GFS, a Global Forecast Systems model, developed in the US, put out there. It's not the European. European's good. I won't argue that. Or the UK Met, which I think is not quite as good as the European or this. But this is a 250 millibar chart. All it is winds and contours. Notice high pressure down here aloft, low pressure here. I want you to track this low. This is a 5-day loop. If you looked at this and said, oh, this isn't going to change, then I would be an easy forecast, right? Continue the same thing for the next 5 days. But let's take a look at this. I want to see how the models are going to react here. What I'm noticing right off the bat is high pressure sitting out here. Oh, usually when I see high pressure over northwest Canada, I think there should be a trough of low pressure somewhere here in the eastern US. So when I have that to start with, I'm expecting this low to move, and it is. It's moved east now. Notice that the high pressure that was down to our south is shrinking, getting pushed to the west with time. Notice the jet stream picking up energy here in the southern part of Canada, and that trough now is all the way over Hudson Bay. We have all these northwest winds coming in, and even more northwest winds. The jet's gotten stronger. So we're building high pressure back here, low pressure out here with time. And that is going to be pushing that high out of the area and probably bringing colder weather in from Canada. So let's go back and take a look now at the surface. Again, with this model, there are others we could choose from, but we're making a forecast, and I'm making it as simple as I can. We're just doing 5 days. So all we have here is surface, 850 millibar temperatures, and with that, we have moisture, precipitation occurring. So you can see the model was forecasting the precip here. But here is 0 degrees Celsius. I consider 0 degrees Celsius is actually cold enough to make snow at the surface. Now there's some pretty cold temperatures. Notice they go from 0 all the way to 21 degrees Celsius here. A 21 degree temperature gradient in Celsius, which means just 40 some in Fahrenheit. And with that, we're seeing it come down out of Canada. Notice that high that's sitting there and that low that's over here where we saw the upper low as well. Cold front probably down around this area right now, down through this low here. And we can, through 5 days, if I wanted to look specifically at the 5th day here, go to the last one, which would be on Thursday of next week. I now have a cold front coming out of this low down through Virginia. Ohio is now in the cooler air, significantly cooler. Your temperature went from 21 Celsius, 3, 6, 9, 12 Celsius in some parts, 12 to 15. You've cooled off 6 to 9 degrees Celsius. That is quite a lot. So yes, this is a significant cool down. Things are changing for a little while. That trough that was out over the upper Canada and the big high that was over most of the United States is dissipating and going away. So what we're winding up with is a significant cool down starting towards the middle or the end of next week. And that's how you go about forecasting. We have the front that's going to go through. We have the showers now. Until this front goes through, we may have a continuation. Some days a little more, some days a little less. And eventually it all goes cooler and drier. Matter of fact, this might be some of the coolest weather we've had this summer. And very dry. So it should be a pretty pleasant end of the week next week. So if you have any questions about this, please ask me.